Hello guys, welcome to another episode of GeeklyEDU. My name is Eddie, and today we're going to continue to talk about indeterminate forms. In a previous video, we explored indeterminate forms of the shape 0 divided by 0, infinity divided by infinity, or 0 times infinity. Fourth one is going to be infinity minus infinity. And let's do a little example to exemplify this. So we're going to have limit as x approaches 1 from the right of 1 over natural log of x minus 1 over x minus 1. So if we try to plug in the value into the function here, which let's call it f of x. If I try to evaluate f of 1, then both terms would go to infinity, okay? Because logarithm of 1 is 0, 1 minus 1, 0, so infinity minus infinity. Okay, so this is an indeterminate form. Now, what can we do? Well, very simple. First thing, we're going to rearrange how everything looks. And it's going to be our go-to move when we have an infinity minus infinity types of limit. So we have limit as x approaches 1 from the right of x minus 1 minus the logarithm of x divided by the logarithm of x times x minus 1. And at this point, if we try to plug in the value, we realize that now we have is 0 over 0 indeterminate form. Okay? And as we remember, whenever we have 0 over 0, we're going to use L'Hopital rule. Basically, after I do that, we have the limit x plus, and then it's going to be 1 minus 1 over x divided by negative 1 over x, and then I'm going to have the derivative of x times logarithm of x, so it's going to be logarithm of x plus 1. So we have all of this. And what do we do again? Because we still have an indeterminate form there, we apply L'Hopital again. Now we have limit as x goes 1. Going to be negative 1 over x squared. Then here it's going to be 1 over x plus 1 over x squared. Okay, all good so far. I'm going to move things around a little bit, and eventually I'm going to end up with negative 1 over x plus 1, which is going to be equal to negative 1 over 2. So this is going to be our solution. So then, whenever we have infinity minus infinity, we're going to try to rewrite of x to go to one of the indeterminate forms we talked about before, 0 over 0 or infinity over infinity. The second indeterminate form we will be talking about is going to be 0 to the power of 0. Okay? To exemplify that, we're going to have this limit as x approaches 0 on the right of x to the power of x. And then 0 over 0 is an indeterminate form because 0 to raised to whatever power should be 0. But then any number raised to the power of 0 should be 1. So then we don't know if it's going to 0 or if it's going to 1. And that's what we're trying to find out. Now, to do that, we're going to play a little bit with the expression. So first thing, I'm going to call this f of x. Okay? And then I'm going to rewrite f of x in a very specific way. So f of x is equal to e to the power of the logarithm of f of x. And this will make sense soon. But remember, whenever I have e to a logarithm of x, for example, this is just x. So I can write x like this, or I can write it like this, because it's the same, which is what I'm doing here. Now, if I have the limit when x approaches 0 of f of x, then that needs to be equal to the limit as x approaches 0 of e to the power of ln f of x. Now, e is just a number, okay, and the exponential function is continuous for any real number. Therefore, I'm going to do a little trick, and the limit can go directly on the exponent, like this, right? And this is just a property of limits. It's the same thing that you can do with a sign. For example, if you have a limit of sine of x, you can put the limit inside the sign or inside any function as long as the function is continuous for all real numbers. Now, what is the logarithm of f of x? Well, that's going to be the logarithm of x to the power of x, which is going to be x logarithm x. Now, what does this mean? Well, this means that the limit as x approaches 0 of f of x is actually equal to e to the limit x approaches 0 on the right of x natural log of x. Okay, so maybe this looks a little bit better. Let's see. So if this approaches 0, I would have 0 times infinity. Not great, but it's an indeterminate form we already know about. So we know that we can rewrite that limit like this. Logarithm of x divided by 1 over x. And now I have an indeterminate form 0 over 0. So what am I going to do? You guessed it. The Tal's rule. Again, that doesn't modify, doesn't do anything to the e. And I'm going to end up with 1 over x. 1 minus x squared. This is e to the limit. So I'm just going to have negative x, which is going to be equal to 0. And the final solution is going to be 1. Okay? Now, this thing I did right here is very important, so you can take your time and look at it again, because for all the next indeterminate forms we're going to talk about, I'm going to use this exact, let's say, trick. All right. Now, then we have number 6. 1 to infinity. Now, 1 to the power of any number should go to 1. Any number to the power of infinity should go either to infinity or to 0. So, we have an issue. We have an indeterminate form. And to study so, we're going to use the limit x goes to infinity of 1 plus 1 over x divided by x. Okay? Now, what are we going to do in this case? The exact same thing we talked about before. So we already know that I can rewrite this limit as e to the limit as x approaches infinity of what? Well, this is f of x. So, in this case it would be the natural log of f of x, which is x times natural log of 1 plus 1 over x. Alright? And then we see what type of indeterminate form we have at that point. So, we have infinity that multiplies logarithm of 0. So we have 0 times infinity. But as we just did, we're going to rewrite this in a specific way. So I have b, and then I'm going to have natural log 1 over x divided by 1 over x. And now we realize that we have a 0 over 0. Therefore, you guessed it, L'Hopital's rule. This is e limit x power infinity, and then I'm going to have negative 1 over x squared that divides 1 plus 1 over x, all this divided by negative 1 over x squared, and say divided by 1. So this is going to be e to the limit of x approaching infinity. This is going to cancel out with this, and then I'm going to end up with 1 over 1 plus 1 over x. This is limit x approaches infinity of x plus 1. Okay, so we have an infinity over infinity. We're going to use L'Hopital's again, even though it's not necessary at this point, but just to make sure. And basically have the limit of 1 over 1, which is limit of e to the power of 1, which is e. And that's going to be the solution. So then, sorry, once again, the trick is always to do this conversion right here. Okay? So if you have a 0 over 0, a 1 over infinity, or our last type, which is infinity to the power of 0, we always do the exact same thing. So very quickly, we have the limit, x approaches infinity, of x to the power of 1 over x. So I'm going to leave this to you guys as homework, and then you can leave your comments, answers, questions in the comments below. But remember, so the setup will be the same. This will be f of x. We want to rewrite the limit as x approaches infinity of f of x. And the only way to do so, in this case, is to write it as e to the limit as x approaches infinity of the logarithm of f of x, where we know that the logarithm of f of x is going to be 1 over x times the logarithm of x. So, please let us know what answers you got, If you have any questions, don't forget to like and subscribe. We're posting videos almost every single day. If there's something that wasn't quite clear, let us know. We'll try to reach out to you as soon as we can. And yeah, that's it for today, guys. So I'll see you on the next one.